What's up, Algebra 1? Today we introduced the concept of function notation. So we talked about what makes something a function. The definition of a function is no repeating x values, meaning if you were to have a list of points in a table, 0, 1, 2, 3, 5, 6, 7, because all of the input values are different, we would call that a function. But if you had a function, if you had an equation that repeated an input, where like, for example, 1 gives you 6 and then later 1 gives you 3, well, this is a problem because the input of 1 is mapped to two potential outputs. And what we talked about in class today is for machines to function, and that's what this is really all about, to program a machine to take user input, I do not want a button of input to be mapped to two possible outputs. For example, if I press spacebar, it only goes to the next page. It never does anything different. And so it functions in that way. That one spacebar input is mapped to one possible output. Now, when we talk about graphs, anytime you're given a graph, and today we talked about naming these. For example, this is a linear graph. Lines are considered functions because when you were to study their input-outputs, there's no input that's mapped to two different outputs. And the reason why you know that is what we call the vertical line test. If you're to draw a vertical line over this graph, it's only crossing once, as opposed to something like this, where it would cross twice. And that's a problem, and that helps us determine that it's not a function. So, this is all about function notation. It's basically practicing the calculations that computers do when you are mapping input into an equation and you're getting out some value that's being used in the program. So for example, I need to look for the name of the function. So this is called g of 10. Now I'm going to map it to the correct function, g of x. So I need to be making sure that I use the correct function each time. For example, this one's j of -8. So I need to use j of x when I calculate that one. So let's talk about the first one, g of 10. The equation is -3x plus 1, but because they've replaced that g of x with g of 10, they are suggesting that the value of x is 10. So I want to replace the x value in the expression or in the equation with 10, and then do some calculations. So if you want to use a calculator, you sure can. Plus 1. So that should be -29. So essentially -3 times 10 is -30. If you add 1 to that, you're getting -29. And so that is your output when your input is 10. So all of these on the front page are input. They all have numbers that are in parentheses, which suggests that is the input value. So we're going to do several here. -3x plus 1, I'm using the same function, g of x, but I do have a different input value. I am inputting -7. So -3 times -7, that'd be +21, and if you add another 1 to that, you get a final answer of 22. So let's kind of walk through and do a few of these. They use different functions. So for example, number 3, they're having you do f of 3. So I'm trying to think about which function to use, which hopefully that's pretty easy for you. F of x, I want to use the one that is named f. So that is x squared plus 7. That's the equation for f of x. But I'm plugging in the number 3. So 3 squared would be 9, and if you add 7 to that, you're getting 16. So if you plug 3 into f of x, you get out 16. J of -8. So I'm going to look for a different function. I'm looking for j of x, which j of x is 2x plus 9. And if you notice, I replace x with this parenthesis. I'm creating a space where I can input the value -8 in for x. And this is just really going to make sure that I calculate things very carefully and correctly. So 2 multiplied -8, that'd be -16. And if you lost $16, but your friend felt bad for you and gave you 9, it's almost like you only lost 7. Getting closer to have lost nothing, but that doesn't quite make me money in the sense that I have positive value. So negative 16 plus 9, negative 7. All right, h of negative 2. So I look for h of x, which is this equation here, and it says it's 12 divided by the input value. So 12 divided by x. Now, you don't really have to use parentheses for this, but we're talking about it. I'm showing you where that x value is going. It's going in the denominator. And this is division. All fractions are division. So to do that in the calculator, 12 divide negative 2 would be negative 6. So if you ever wonder, how do you do a fraction in a calculator? Fractions are using division between the numerator and the denominator. Now, h of 24, 12 divided by 24, let's be careful. This is not 2. The order in which numbers are divided matters a lot. So if I said 12 out of 24 people like mayonnaise, then really that is 50%, or like half of the people like mayonnaise. I like it. So this would be 1/2, or if you wanted to, you could say it's 0.5. But it's not 2. If you think it's 2, try to flip them. 24 divided by 12 is 2. However, when you flip the order there, it's not the same. Some operations are what we call commutative. For example, addition. 1 plus 2, 2 plus 1. The order in which you add does not matter. That's called the commutative property. Same thing with multiplication. 4 times 5, 5 times 4, they're both 20. However, subtraction and division don't work this way. 4 minus 5 and 5 minus 4 are different. Sorry, 5 minus 4. They're similar, but they're not exactly the same, so that's not what we call commutative. Commutative, C-O, change order. Not everything can do that. So, a few side notes as we talk about function notation. So, I want you to try a few. I want you to try 7, try 9, you can try 10. But I'm going to show you guys a music video that I did with my class last year about how frustrating it is to teach students that do not use parentheses carefully. And especially when you are squaring negative numbers. Or really, to be honest, anytime the exponent is even, it really matters that you use parentheses. So x squared plus 7. I am inputting the value of negative 10. And so this is what I am referring to. If you were to use parentheses, you are forcing the calculator to understand that I'm doing negative 10 times negative 10. And that should be a positive 100. Of course, add 7 to it in the equation, and this should be 107. Final answer. Okay? But if you were to be in a hurry and just type in negative 10 squared plus 7, the calculator doesn't receive the understanding that you want it to understand. For example, this first part, this calculator believes you mean this. Sorry, I missed the 1 there. The calculator thinks you mean this idea, but you really want negative 10 against, grouped so that it knows you want negative 10 to multiply times itself. So I show you this because this is why many students struggle to calculate it correctly, even with a calculator. So please use parentheses, especially when the powers are even. For example, negative 10 to the 4th, that would matter. Because if you were to not use parentheses, you are not going to get that exponent out to be the same. Sorry, I'm struggling here. See? It matters because I didn't use parentheses. Now, odds don't really matter because you have an odd number of negatives. Even if you were to group it, you're going to have an odd number of negatives. So it really just matters when it is even. Okay? I want you to try 11 and 12. And try 13 and 14. Let's see what other problems that we don't quite have here that maybe we could finish out. Let's do these last 4, and then you can try any of the other problems that you see. So h of -6, I want to find the correct function. That's that third one, 12 over -6. That calculates to be -2. Simple input, simple output. 12 over 120. So I want to really be careful here. 12 over 120. So I could either think of that as 0.1, or I could also consider that 1/10. So I'd take either answer, but I'll tell you 1/10 is really the best answer. I mean, yes, it is 0.1, but the best answer is a 10th. Okay. 2x plus 9, that's my j value, j of x. I'm plugging in -19. So let's carefully 2 parentheses -19 plus 9. That ends up giving you -29. You can try this one since it's very similar to one that I've already done. So there's some that we did in class that I want to return to because I did assign both sides of the page. Sometimes it's not input. Sometimes you're looking at the output. So let's look at one that's similar to that. This one here is not the same. If you notice, it's not using -5 in the parenthesis. This means something completely different. This means I do not know the value that x is. I don't know what to plug in, but I know the outcome. I know that when I do 20 divided by some number, I better get -5. So you could probably think about this for a moment. 20 divided by 1 would be 20, and 20 divided by 2 would be 10. And you could kind of think through what this number would be. But let me show you some ideas that we could kind of flex to solve this. I'm dividing by x. Let's multiply x to the other side. 20 equals -5x. Well, if I wanted to get x isolated, get x by itself, then I could divide -5 back over, and it looks like x has to be -4. And this is the answer, because if you do 20 divide -4, you get -5. So again, you didn't know the input. You knew the output. The goal was to find the input, and that's why we solved it by setting it equal to the outcome, setting the equation equal to what it should be, and then solving out of that. Let's look at another one that's doing that. Like I see h of x equals 1, so it's using the same function. So I want you to try that same idea. I want you to multiply x to the other side and then divide 1 back over. Or just think, like, what value would x need to be? 20 divided by what would be 1? Okay, so I'll leave that one for you to think about. Okay, so I wanted to talk about this last one real quick. F of x equals 60. And if you look up that equation, that f of x equation is x squared minus 4. So I want to set my equation equal to 60. I don't know what to plug in. So I want to start solving again by using what we call opposite or inverse operations. So I have to think, well, what minus 4 would be 60? Well, you change that operation to be its inverse and move that number over to the other side, you can figure out that x squared better be 64. Like 64 minus 4 is 60. Well, we have to think about what number squared would be 64. So just a quick lesson about squaring. When you say a number is squared, it means that number is times itself. So we kind of maybe think about what number we would need. And that turns out to be 8. 8 squared is 64. Well, the opposite of squaring would be square rooting. So if I was to square root 64, that would show me what number multiplies against itself to be 64. So that's really the best thing to do in this last step. The opposite of squaring is square rooting. And one thing that we'll learn in several weeks from now, not necessarily today or tomorrow, when you use square rooting to solve, you really want the positive or the negative, because not only is 8 squared minus 4 60, but negative 8 squared minus 4 is also 60. Give those other problems a shot. We'll look at them tomorrow. Please bring your questions in. Good luck.